And so I already have a project pulled up in Workbench, so we're going to go ahead and open a new design model or geometry. And I'm going to do the 45-degree plate. It's just a cool kind of aspect. You get a little bit of both. You get a little bit of viscous drag and a lot of bit of pressure drag, so it's cool to see. So what we're going to do here is start by sketching a rectangle. And so we have 3-point rectangles, so we can kind of start with an angle. And then we can go ahead and start dimensioning. Start with the angle and make that 45 degrees. And then we can grab our general dimensions and do this. We can also convert over to centimeters because that's what the project calls for. It'd be a little easier than converting afterwards. So the length of the plate, the length of the plate is 30 centimeters, and the width of the plate is actually 0.1 centimeters, so pretty tiny. But we can zoom in and get a little bit of a look at that. And then we need to draw one last thing, which is going to be a rectangle around the entire plate, I guess you could call it. One thing I've noticed about this, you kind of want to go a little higher on the top and bottom because this 45-degree plate gives you a lot of you'll see what I mean. But also, I'm sorry for the background noise. It is pouring rain, and so it's going to be a little noisy. But what we can do now is go back into modeling and select this sketch here, create a surface from the sketch, and apply. Generate. And you can see we have a surface here, but just to check, we can zoom in and see that our plate is actually there. So that's pretty much it for geometry. We can jump in now to meshing. And some of this takes a good bit of time. And I found with Fluent, if you're not patient, it's not patient with you, so just gotta let it do its thing. So our mesh came up there, and there it is. There's our plate and our surrounding surface area. So we'll just do the standard insert new method. We can select this geometry, go ahead and apply. Coming back to mesh, we can change the element size. I found 50 millimeters is a good happy medium. I've tried to go smaller, but it either takes too long or ends up failing. So 50 millimeters seems to be good, but then I'll add on top of that a refinement of around 2 to 3. Both seem to have worked fine, and then we'll generate this all at once. And this is the part that kind of takes a little bit of time, arbitrarily. Oh, yeah, see, sometimes it's fast, sometimes it's not. And checking, we have a pretty decent mesh. We could probably make those element sizes a little smaller, but for the sake of the video and for all of our time, I'll keep it as that. So last thing to do before we leave our mesh is to go through and name all of our surfaces. So we'll call this the top wall. And the notation I've kind of been going with is using like leading wall. And that way I can kind of keep it the same and trailing wall across all the different, the 3 different setups. Seems to have worked out decently. Rather than calling it like top and bottom, because it kind of changes. So bottom wall. And then lastly, we can do our surrounding area. So we can actually name these together as symmetry. And what I've found a lot with this too is that these outside ones that I'm naming now, if you name them properly, Fluent will pick them up properly once you get into Fluent. So if you name these inlet and outlet and that one's symmetry, you really shouldn't have too much problem with setup. You shouldn't have to change too much. So there's all of our name selections. We can now go back to Workbench and update our mesh. Yeah, if you take the time and name those properly, it seems like Fluent picks everything up properly and you really don't need to change anything. Go ahead through our setup. Double precision. I run 2 processes. I I've done more, but this one really doesn't take that long, so I don't see a reason to. I'm also running on Parallels on a MacBook, so I don't know really the capabilities of Parallels. So I always wait for that console to say done before I do anything. Fluent is a little bit temperamental with this kind of stuff. So first thing we're going to do is jump into models here and go into our viscous setting there. We change this to K epsilon. We go enhanced wall treatment and pressure gradient. And to be completely honest, I'm not 100% sure on all of the influences of these settings, but I do know these three kind of in combination gives you some sort of turbulent effect from what I'm understanding from talking to Dr. Ozbay and talking to a couple other students. That's kind of what this is doing. Next we can go into materials, and you really don't need to change this, but the project does call for 1.2 kilograms per cubic meter for the density and 1.8 kilogram per meter seconds for the viscosity. So really not much of a change, but if the project calls for it, I'll do it. So that's it for materials. And the big thing here is boundary conditions. This is what I was talking about with naming. Because we named all these properly, if we click on inlet, we get velocity inlet already. So we can go ahead and change this to our velocity that we want, which for this project it's going to be 15 meters per second. Apply and close. And you can see the bottom wall, interior surface interior, leading wall is a wall, outlet is already a pressure outlet. Symmetry is already taken care of with symmetry, top wall, and wall. So we're all good there. That's all you have to do if you name them properly. And then we can go to our reference values. We always want to compute from the inlet. And I seem to have better results changing this to about 0.5 meter. So yeah, that's pretty much it for the entire setup really. So then we can go ahead and initialize. I've also been getting this warning. I don't know what for. First couple times I did it, I didn't get that warning. And recently I have. I've tried changing things to fix it, but it also doesn't seem to have any effect on the calculations. So I just kind of been moving on from it. So we'll bump this up to 100 iterations, and it really shouldn't take that long, but we'll see. Runs fairly quickly. It looks like it's going to do all 100 iterations. Okay. So before we jump into results, we can go to the results tab here and make ourselves a new contour. And I'm going to do, just change this to velocity. And I'm going to do a velocity contour. And we'll compute that and save and display. And I honestly think that these contours look better than the ones in the results tab, but maybe I'm just doing something wrong. But we can go ahead and increase the size of our scale if it'll let me. There we go. Move that in, and we can see really good contours actually in this kind of setup thing. So let me grab movie roundy tool. You can see our flat plate here. We have obviously zero velocity touching the plate, and then we get this sort of acceleration going across the top, acceleration going around the bottom, and then we have this big area of low velocity, which is kind of what you'd expect there. You get this big wake region from the 45-degree plate. Before we go into results, I want to do one more contour, and this will be our pressure contour. Because again, I honestly like these. That's spelled wrong. These contours better. They're a lot smoother looking and a lot easier to do. You just select your variable and you want, and there's our pressure contour. So you have this area of really high pressure. This is really a big area of low pressure, which obviously is why we get pressure drag, right? Pressure wants to go from high to low, so it's going to be trying to push this way and creating that pressure drag. So last thing before we leave Fluent, if you want to get your results, you can come down here into Report and Forces. And you can either, well, first things you want to select all of your wall segments, and you can either print this right to the console or write it. For now, I'll just do print, and you actually do, just from printing to the console, you get a nice display, a nice chart of all your forces, viscous and pressure and total, and it gives you all your walls right there. So lastly, we'll go into results, just a quick little check it out before we wrap this one up. Come normal here. And we can make a new contour. First of all, we'll do a velocity contour. And for our location, we'll do symmetry. I'm not sure what the difference between symmetry 1 and 2 is. This one seems to have a more defined plane here, but we'll try both. And lastly, we go to velocity, and we will bump this number of contours up. We'll try 100, see how that looks. And we get this really nice display. Super similar to what you saw in Fluent, but a little bit of a better scale. You get some more options to choose from here. But you can see our plate there and the same velocity contours we saw before. We'll make one more for pressure. I kind of like that symmetry 2 setting a little bit better. So we have pressure selected here. We'll change this to 100 and apply. Turn off velocity. And there's our pressure contour. You get your high pressure region here, your low pressure region here, which is the reason for pressure drag. And it's pretty interesting actually. From these two contours, you can visualize your drag. You know, like here you can totally visualize your pressure drag. You have this high pressure here, this low pressure here, and if we go back into velocity, we can see why we get viscous drag, right? We have our incoming velocity right around 15 meters per second, and then we get this total like stagnation, this no slip condition of zero velocity, which is dragging and acting on that plate. So that's your visualization of your viscous drag, and as we said before, that's your visualization of pressure drag. So that is pretty much it for this one. So hope you guys enjoyed that. Hope I didn't take too much of your time, whoever's watching this. So thank you again, and yeah, bye.